Welcome, everyone. I'm Amanda Nicholson, Director of Finance and Operations at the Product Stewardship Institute, also known as PSI. We are pleased that you can join us today for Rolling Out the Carpet to Recycling and the Circular Economy, our two-part web symposium with carpet EPR experts, U.S. carpet recyclers, and U.S. manufacturers using recycled carpet polymers in new products and packaging. Yesterday, in part one, we learned about the forces driving the recent surge in carpet EPR bills, CARES initiatives to increase recovery, reuse, and recycling of post-consumer carpet in California, and new carpet EPR models being proposed in Illinois, Minnesota, New York, and Oregon. If you missed it, don't worry. The recording will be available shortly on PSI's website. Today's session centers around technologies that are putting the carpet circular economy into action. In our first panel, we'll hear and see how carpet is collected, transported, and processed, the technical advancements that have increased the quality and utility of carpet polymers, and the positive impacts on municipal carpet collection. In our second panel, we'll see 4 circular applications of recycled carpet feedstock. Presentations from Eastman, PureCycle Technologies, Aquafil USA, and RISE Composite Technologies will demonstrate how recycled carpet polymers are produced and how they are being used in new products, from packaging to fashion to building materials. Wrapping up the day is a presentation from Environmental Advocates New York in the environmental imperatives driving the need for enhanced carpet recycling. We invite you to stay with us after the last session for an extended Q&A period and discussion with our speakers. We have a tremendous lineup of speakers with us today from public, private, and nonprofit sectors. Welcome to Franco Rossi, Chris Layton, David Bender, Tamsin Etafa, Doug Mankosh, Walter Willis, and Kate Carrera. And today's moderator is our very own Scott Cassell, CEO and founder of the Product Stewardship Institute. But before I move on, I'd like to pass the mic to Brendan Adamczyk, who will cover a few logistical items to ensure everyone's able to participate smoothly. Brendan?
Yeah, thanks, Amanda. Hi, everyone. I'm Brendan Adamczyk, an associate for policy and programs here at PSI, where I work on EPR for carpet, as well as paint, packaging, and solar panels. My colleague, Gabby Queenan, and I will be providing tech support for today's event. Gabby, would you like to say hi?
Hi, everyone.
Thanks, Gabby. So for this webinar, next slide, you have the option of joining via telephone or computer audio. To select your audio options or switch audio during the event, just click on audio settings in the lower left corner of your screen. From there, you can also test your speaker and mic or switch between multiple audio devices that may be connected to your computer. You can also change your view of the screen, as you can see here. To select or exit full screen or to zoom in or out, just click on View Options at the top of your screen. To ask questions, click on the Q&A icon located at the bottom center of your screen. Whether you have a technical question, such as help with your audio or video, or a content-related question, such as clarification on a particular point that a speaker has made, please feel free to type your question in the field that reads "Type your question here," and then just click the Send button. Gabby and I will answer any technical questions that you may have, while our moderators, Amanda or Scott, will ask the content-related questions aloud during the Q&A period at the end of each part of today's session. Lastly, all of PSI's events are recorded, so you can listen again or catch any that you've missed. The recording of today's event will be posted to the Carpet Symposium webpage within 48 hours. You will receive a direct link to the webpage via email after the event. Next slide, please, Amanda. And you can also find the recording of today's event and other web events put on by PSI in the past in the on-demand webinar section of our website. As you can see on our screen, just click Events at the far right of the menu, then click On-Demand Webinars. And I'll turn it back over to you, Amanda.
Thanks, Brendan. Now, without further delay, I'd like to hand the mic over to Scott Cassell for our first panel.
So thank you very much, Brendan and Amanda. I appreciate that. And now I'd like to welcome our first two speakers, David Bender and Walter Willis. David Bender is has deep knowledge and has a passion for recycling. I will say firsthand, also a passion for cigars. His company, Circular Polymers, is an industry leader in converting plastic waste into raw materials for the circular economy. Walter Willis has overseen solid waste and resource management programs as executive director of the Solid Waste Agency of Lake County, Illinois, otherwise known as SWALCO, since 2007. He's a board member of the Illinois chapter of SWANA, which is the Solid Waste Association of North America, and of the Illinois Food Scrap Coalition. He's also a board member of the Product Stewardship Institute. David and Walter will show us how carpet's collected, transported, and processed, and we'll discuss the benefits of improved carpet recovery and recycling. We're going to have presentation first by David, then by Walter for about 15 minutes, and then we're going to have an audience Q&A. So as Amanda has mentioned, and Brendan as well, send in your questions in the Q&A box as soon as you have them. And with that, I'd like to turn it over to David.
Thank you very much, Scott. Thank you, PSI, for putting on this important symposium. Very honored to be up here with an important group of panelists, and Walter and I look forward to conveying some information before we get to the headliners and the producers. So I thought a good way to start here would be to be a short video. I will say that carpet collection and processing has really come a long way over the last 5 years, and is being upcycled into some tremendous applications that you will hear about shortly. So Amanda, if you wouldn't mind rolling that video, I'd appreciate it.
Make it a little louder. Thanks.
Consumers, companies, everyone is talking about plastics, and the time is right for us to really be able to leverage our knowledge, our expertise, and our innovation, and our people to create a solution unlike anybody else's.
So I just want to say before we start, which, this was something we put together with Eastman, but you're going to hear, great stories following with a bunch of outstanding companies who are all upcycling carpet waste and putting it back into the circular economy. It's just so very exciting. So let's talk about some basics here. Let's first talk about new carpet. When people buy new carpet in the United States, almost everyone has it professionally installed. And what I mean by that is an installer is going to take the carpet from the carpet retailer or their warehouse, bring it to a home, an apartment, wherever they're installing the carpet, and they're going to remove the old carpet and put it back in their van. And the day starts early in the morning and it goes until late in the afternoon, and every day is a repeat. And at the end of the day, next slide, please. They're either going back to their retailer with waste. And it could be their retailer, or it could be a landfill, which we'll talk about in a second. But at the end of the day, this is our opportunity to capture the carpet waste. We've already solved the hardest part. The hardest part is how do you get it out of the home? But with 90% or over 90% being professionally installed, we've solved that. This is a great, what I call alternative feedstock from the bin to be removing the carpet waste. This is a picture of a of a trailer, of a bin that one of our partners, Green Waste, out of San Jose, uses, and they're going to, this bin is going to get filled up at the retail location, and the retailer is going to make a phone call to Green Waste. The number is right there on your screen, and a little call out here to Wes Nelson, who runs that division for Green Waste. And Wes is going to make sure that they come and pick it up and swap it with a new one. Next slide, please. And this is a picture of the landfill. A little bit more industrial, a 53-foot trailer. They're going to make sure it is fully loaded, and same thing. It's going to be, it's important that it's in a trailer so it's kept dry. And once again, when the trailer's full, there's going to be a swap. Next slide, please. So there's different kinds of carpet. There is residential carpet and there's commercial carpet. And there's something called tile. It's in many office buildings throughout this country. It's modular, and both are really important products that can get upcycled into the circular economy. Next slide, please. So what is carpet? Carpet is plastic, sand, and glue. It's different kinds. It's face fiber, which is usually nylon 6, nylon 6/6, PET or polypropylene, with some backing fiber. In this case, that's usually polypropylene, and some calcium carbonate and glue. And circular polymers, as a reclaimer, our objective is to process that into a raw material so we can hand it off to the manufacturers and to the advanced recyclers to further refine it or make it into a product. Next slide, please. So a little bit about circular polymers. Circular polymers is located in Lincoln, California. That's just outside Sacramento. Next slide, please. We have 2 production lines in a 150,000 square foot building. We have an annual capacity of about 50 million pounds, and we're producing both a fiber output and a pellet output. Next slide, please. Comes in. The first thing we need to do is sort it, and we're using FTIR technology, which is identifying the face fiber of the carpet. And again, that's usually either nylon 6/6, nylon 6 PET, or in this case, as you can see it on the FTIR infrared handheld, polypropylene. And what we're doing is we are segregating the carpet so that we are running only polypropylene, only PET, only nylon 6 or only nylon 6/6. And this is done universally, not just at Circular Polymers, but of my peer companies, people like LA Fibers. Next slide, please. So we're fortunate enough that we have a proprietary technology that was developed by the Broadview Group out of Ohio, which produces a very high quality fiber, but in a dry environment. I mean, that's really important, is that, using a fraction of the energy, we're able to both separate the sand, which is the calcium carbonate, from the fiber, and then we're also actually able to separate the backing fibers, which is usually polypropylene. So in the case of PET carpet, we can have a PET product, polypropylene product, and a calcium carbonate product. Next slide, please. Can you hit that play button on that? So, you know what carpet looks like, but at the end of the day, what comes out is kind of, in the industry term, known as fluff. And this is the feedstock. So that fluff is carpet fiber with very little sand and glue in it. And it can remain in this form, or it can be pelletized. Next slide, please. So I know this is a complicated chart, but the point of this is that we have both fiber solutions and pellet solutions, and it depends upon the customer. Some customers don't need it in a pellet form and can handle it in fiber form. Some customers need it in a pellet form, and there's different kinds. We actually densify it on site, or we will or we will have it further processed either through a compounder or an extruder into a melt filtered pellet. But our objective is to put as little energy and as little cost into the reclamation in order to make it a raw material that the next set of speakers will talk about, you know, what it is that they take this product and do something with. But how do we get this back into the circular economy? Next slide, please. So where does all this go? Okay, so here we are at Circular Polymers reclaiming millions of pounds of carpet. And again, it depends upon the face fiber of that carpet. So on the nylon side, we're sending it into automotive markets, textile, fiber, composite lumber, composite wood, and advanced chemical recycling. On the PET side, we're able to, you know, put it back into packaging, beverage, textiles, composite lumber. In the polypropylene side, it can go into typical injection molded space or into consumer packaging. Now, some of the fiber sometimes is either PTT or mixed face fiber, you know, and there we have to be careful about what applications we go into, either mixed fiber applications or composite lumber. And then finally, we have calcium carbonate, which today goes into, you know, road materials and into fillers. Next slide, please. We are very fortunate at Circular Polymers. We won some, we won a whole bunch of awards in 2019 as we demonstrated our technology from the Broadview Group. And we just feel very fortunate to have received the awards, and we're very, very grateful. Next, please. At this point, I'll turn it over to Walter. Next slide, please.
Thank you, David. And now we'll hear from Walter Willis from Solid Waste Agency of Lake County, Illinois. Walter?
Thank you, Scott. Good afternoon, everyone. Walter Willis here. I'm going to, next slide, Amanda. Give you a little background on kind of the history of carpet collection in Illinois. And I've been infatuated with this material since I met Nick Fiore over 10 years ago. So he was running a very successful business in the early 2010s. Over 80 retailers were working with his company. They found it cheaper to work with him than take that carpet to landfill. So it was a good business model. And at that time, most of the carpet was still nylon and had good value in the marketplace. That whole experience, getting to know Nick and seeing that carpet could be recycled like that, led me to form the Illinois Carpet Recycling Working Group. We did a lot of work on trying to collect more material. We actually got several construction and demolition debris facilities in our area. We have recycling facilities for C&D. Get intrigued by this, and so they made efforts to work with Clear in 15 and 16 in that time frame. But that's when the PET carpet was starting to take over the nylon, and unfortunately, when the construction and demolition facilities would divert the material, and then it would get shipped to Nick or Clear, a lot of the material that like the PET was shipped back to the C&D people as waste. And they just, at the end of the day, that just wasn't working for their business model, unfortunately. So that kind of fell apart on us, even though we had great hopes there. And really, it was down to the oil prices were low, and then the significant growth in non-recyclable, at that time, non-recyclable PET carpet. So, and as far as what's going on right now today in Illinois, there's only one facility, DC Foam, in North Lake, Illinois, a suburb of Chicago, that only takes specific types of carpet and padding. I don't even think it's 3% recovery. I think it's like 1% recovery. So it's a significant struggle to try to collect carpet without the extended producer responsibility. So next slide, please. Senator Melinda Bush is from Lake County, where I'm from, and she's been engaged in this material. Zion, where Clear had a plant, was in her district. she's grabbed onto this topic and is very sincere about wanting to get carpet out of the landfill and create the circular economy. So we did introduce a law in 2015, and the carpet manufacturers, were opposed, and we're willing to work with the senator on trying to do a voluntary approach to collecting carpet. And we had significant meetings, et cetera, with the carpet industry, peoples as well, and at the end of the day, the voluntary approach just did not seem to be getting traction and wasn't allowing us to collect more carpet. So I guess to me, it was a good attempt, but it was ultimately unsuccessful. So next slide. That's my last slide. Okay. So what we've done as we have engaged with the other stakeholders that are advocating for the carpet stewardship law in Illinois, that we have really tried to focus on recovering more carpet. California, I think they're close to 24-25% after 10 years. We want to do that after the third year. And people might think we're crazy, but hey, we had 80 retailers just 10 years ago doing this. We think we can bring it back fairly quickly. And so we want to have a very strong goal to start with, and then continue to grow that. Because a lot of the companies that want to come into Illinois are going to be investing significant dollars in their facilities, and they need more feedstock. 25% is not enough. We got to recover more than that. So how do we do that? We modified our bill. We've got the waste industry from neutral to be a proponent of this bill by working with them on these last 3 points. It's not easy to get a waste ban with the waste industry who own landfills, but they agreed to any county with more than 200,000 people, so where most of the carpet's going to be generated. Installers will basically have to use the recycling option. And it's going to be important that they have good options. And if they typically go to landfill or transfer station or C&D facility, we hope to then engage all those types of facilities to help capture the stuff that doesn't go back to retailer. As David was explaining, it's great to get it from the installers. We might end up with 30-40%, but we need to get more. We need to get the material that's ending up in landfill. So the modified landfill ban is part of the bill now. We've explicitly put in there that if anyone collects, I can collect as my agency and get paid $20 a ton. And that there will be grants available from the stewardship group to pay for any kind of sheds or pads or anything you might need. So we really want to get the waste industry excited about collecting this. By paying them, they can still charge their regular tip fees at whatever facility they're at, but this creates an incentive for them to work with the recyclers. And then finally, we have a specific requirement in the bill that installers get educated, that we have to get out there and educate the installers about these other options for recycling. And if you're in a county with more than 200,000 people, you're going to have to use that option. So we really hope to get to 50%, 60%, 70% recovery of carpet. That's the goal of working with the waste industry and building on what David is already doing in California. So that's all I have, Amanda. I think the last slide is my contact information. So.
Great, thanks very much, Walter. And David, if you can come back on as well. I don't see any of the questions in, so let me just ask people again, if you have some questions, please send them in the Q&A box. And let me just ask one quick question for each of you, maybe starting with Walter here. So Walter, you mentioned the policy elements that you put in the bill in Illinois that would provide an incentive for the waste management companies to pull the carpet from disposal and into, let's say, a recycling trailer. Do you think that the 3 provisions that you have in that bill would work well in the other states that have bills? We talked about this yesterday. You have Minnesota, you have Oregon, you have New York as well. Do you think that the same policies might work, or are there conditions in Illinois that would make that special?
No, I think as you look at collection and we look at what California has done, you know, they've got to 25%, but they really haven't engaged the waste industry enough. And that's what we've learned from, you know, David and being out there. And if we're going to capture more, we have to engage the waste industry. And we think this makes sense. It got them off from neutral to being an advocate for the bill. And we're dealing with the big companies, Waste Management, Republic, Waste Connections. They were all on board in Illinois.
Great, thank you. David, quick question for you here. You mentioned all the different end products, if you will, for the carpet and the different, whether it's pellets or different kinds of fibers that go in. You and I have also talked about carpet to carpet recycling. And what do you see as the time horizon for moving to sort of the pure circular economy? I think many people would think where it's carpet to carpet versus some of the other products. Do you think that there will always be this variation? And how do we then get those materials back into the circular economy?
Well, you know, I'll commend Aquafil, who's going to speak later. They're the leaders in what I call carpet to carpet recycling on the nylon side. I see many of the other very large carpet mills following suit as states require recycled content. I mean, we see that coming. We see it in packaging. We all believe that other products will be next, including carpet. And they want to see it from a circular approach, not necessarily downcycling bottles, but reusing their own carpet. And probably it depends upon the polymer, but I think the best way to do that is probably through advanced recycling. And we'll hear from Eastman and we'll hear from PureCycle about how they do it.
Okay. We've got some questions come in. Let me just do one or two quick ones before we move to the next panel. So David, from Rachel Ajayo, do you have certain types of carpet you don't accept?
So the biggest issue with us is wet carpet. So that would be number one. We work very hard with our collection network as well as our collection partners. You saw the top on the green waste trailer as an example, to keep it dry. The other challenge that we have, and we think we'll have this solved by the end of the year, is within the commercial sector, within the tile sector of the commercial sector, there's PU backed and there's PVC backed. And today we don't accept PVC carpet, but we're working very closely to be able to accept that product in the future. And it's more of a, how do we segregate it? Because PVC doesn't like to be near any other polymer for a whole bunch of technical reasons that I am probably not qualified to discuss.
Okay. Walter, quick question for you, and then we're going to switch into the other panel. This is from Gail Bryce. Will Illinois be paying processor incentives like are paid in California?
Yes. Our bill envisions the same types of subsidy program. We've added, the only thing we really added, I mean, we envision the same types of money, the money's being used in the same way, but we have added in the payment for the carpet, which, you know, as we look at the fee and the amount of the fee that would be generated, you know, we're confident that we have the resources to pay for that carpet. So.
Okay. And other states are dealing with this in a different way, which we talked about yesterday, but we'll have to come back to that at the end. We have more questions here, but I'm going to hold them to the end. We're just a couple of minutes over this session. So David, Walter, thank you very much. You're going to be able to stay right after 3 p.m. Eastern here. So those that can stay between 3 and 3:30 Eastern, we're going to have all the panelists come back for the extra questions. So keep sending your questions in as you have them. Thank you. All right, we are going to move now to our next session entitled 4 Circular Applications of Recycled Carpet Feedstock. And as you see here from the slide, we're going to be talking about these companies. We discussed this yesterday. Walter just spoke. He's one of the collectors down here from Swalco. Then that material goes to the processors and recyclers. Well, we heard from David from Circular Polymers. We're going to hear from, and let me get the order right, Eastman, we'll hear from first. Then we'll hear from PureCycle Technologies, Aquafil, and RISE Composite Technologies. So you can see on this webinar, we're looking at the circular economy. And this is how it happens. And these are the technologies that are making it happen. Our first speaker in this session is Chris Layton. Chris is the Director of Sustainability, Specialty Plastics at Eastman, where he works across various markets to leverage advanced circular recycling technologies and helps customers meet their sustainability goals. Chris, the floor is yours.
Thank you, Scott. So as Scott said, my name is Chris Layton. I'm the Sustainability Director for Eastman Specialty Plastics business. And as he also said, I have the really cool job of working across a variety of market segments to help those teams bring to market solution enabled by our two advanced circular recycling technologies. So I'm excited to be here today to share with you a little about what we're doing to try to create a circular economy for plastics. And I'm also excited to learn from my fellow panelists who are also fighting that good fight. Next slide, please, Amanda. So for those of you that don't know Eastman, we are about a $9 billion specialty materials company. And last year, I'm proud to say, we celebrated our 100th anniversary. We're headquartered in Northeast Tennessee, Kingsport, Tennessee, but we have a team of more than 14,000 people located in plants, offices, and research centers throughout the world. And while the Eastman name may not be familiar to you, there's a good chance you use one of our products or a product that contains one of our products because we sell to customers in over 100 countries throughout the world across a wide variety of applications. Next slide, please, Amanda. Our purpose is to improve the quality of life in a material way. And as we thought about that purpose, we thought about the next 100 years of our company, we realized that the world has several challenges that could potentially impact that quality of life. First, and most basically, how do you go about caring for a world that's fast approaching 10 billion people? Secondly, we have a waste problem. Carpet waste is just one of those examples. Lastly, climate is changing, and with that comes a whole host of consequences. So as a result, we've been putting our money where our values are, and we've been investing in two advanced circular recycling technologies. With these technologies, you can take hard-to-recycle materials, like carpet, break them back to the basic fundamental molecular building blocks, and then return those building blocks to the economy in high-value, high-quality applications. And you can potentially do that over and over again. Leveraging those technologies, we've made the commitment to be recycling at a rate of 250 million pounds a year by 2025, doubling that to 500 million pounds by 2030. Next slide, please. So one question we always get is, that's a lot, how big is that? Well, it's a lot. And in short, if you drop that amount of waste plastic into a college football stadium, it would more or less fill that stadium from top to bottom. It's the equivalent of about 11 billion water bottles, a huge amount. But when you put that number in the context of the amount of waste carpet generated every year that Scott shared yesterday, when you put it in the context of the nearly 260 million metric tons of waste plastic generated anywhere, you realize while it's a big number, it's just a small part of the overall problem. And so a lot of work for us all left to do. Next slide, please. As I said, we've been investing in two advanced circular recycling technologies, what we call carbon renewal technology and polyester renewal. Both have been operating at commercial scale since late 2019. And earlier this year, we announced an investment of $250 million in a second polyester renewal asset that, when it's completed by the end of next year, will be one of the largest of its type across the world. Between these two technologies, we can process a wide variety of waste plastics and help address that world's plastics challenge. Our investments are guided by really three principles. First, we're only investing technologies that are taking waste materials to new materials. We're not investing in waste of fuel. Secondly, we're only investing in technologies that allow us to achieve a better carbon footprint than we could otherwise achieve using traditional fossil fuels. And then lastly, we view these technologies as very much complements to the existing mechanical recycling infrastructure. In short, if you can mechanically recycle a material and meet your safety, quality, performance requirements, you should. It's a simple, very efficient process. But the reality is, as we've shown here earlier, a large majority of materials don't get recycled. These technologies can complement what we do, and consequently, we think can help be an important tool in the kit to help address the world's waste plastics. Next slide, please. And can you scroll forward to past the animation? So as I said, there's two technologies that we're operating. The first, carbon renewal. And this is the place today that we are recycling the carpet generated through our partnership with David Bender and team at Circular Polymers. So carbon renewal, pretty robust technology. We can handle a wide variety of waste plastics, polyolefins, polyesters, polystyrene, polycarbonate, carpet fiber, textiles. We take those waste plastics, break them down into the fundamental molecular building blocks, in this case, carbon, hydrogen, and oxygen in the form of syngas. That syngas, indistinguishable from the same syngas that we produce on fossil fuels. And then we can feed those building blocks into our existing chemicals, fibers, and polymer units and produce a whole host of products. And so as David said, the carpet fiber that we get from Circular Polymers gets broken down and it goes into applications like our Naya cellulosic fiber that goes into performance apparel, cellulose diacetate that goes into the making of eyeglass frames, and our Triva engineered biopolymer, which goes into electronic devices and automotive applications. The second technology, polyester technology, as the name implies, is focused on polyester waste. So think not only the traditional clear PET water and soda bottle, think of colored PET, think of thermoforms, films, carpet, textile fibers as well. We take those polyester-rich wastes, break them down to the fundamental monomeric building blocks, materials like dimethyl terephthalate, and like all the monomers that build polyesters. Again, those materials indistinguishable from the same monomers that we can produce on fossil feeds, and then we feed them into our existing polymer lines where we can produce a whole portfolio of polyester, copolyester products, materials like our Triton that goes into housewares, small appliance, electronic devices, medical devices. By taking those waste plastics back to the fundamental building blocks, rebuilding them, we can produce polymers with essentially the same quality, same safety, same performance as we could produce based on fossil fuels. And we can do that potentially again and again. The other benefit, by using waste plastics, you eliminate the extraction, the refining, the cracking associated with fossil fuels. And so as a result, you can produce these materials, this syngas, this recycled DMT with significantly lower greenhouse gas emissions. For carbon renewal, that could be anywhere from 20 to 50% lower. For polyester renewal, 20 to 30% lower. Those ranges depend on the type of waste plastic, how far we need to transport it to get it to our facility, and the type of pre-processing. So not only a significantly good improvement in terms of diverting materials from a landfill, you also have the positive impact of lower greenhouse gas emissions. So again, these technologies can be a big step towards creating a circular economy for plastics. And next slide, I'll show you a short video that will elaborate a little bit. So thank you again for letting me share a little bit about what we do. And with that, Scott, I'll turn it over to you.
Great. Thank you very much, Chris. Appreciate that. Lots for us to think about and talk about. For those in the audience, please keep sending your questions. We're going to hold them till the end of the session. And now I'd like to introduce our next speaker. Tamsin Edifa is the Chief Sustainability Officer of PureCycle Technologies. Her proven ability to deliver growth, revenue, and move the needle in plastics reclamation in North America has shaped her as a seasoned leader and a mover and shaker in the industry. Tamsin?
Thank you so much. If you guys could start my presentation, that would be great. So next. So as Scott mentioned, I'm Tamsin Edifa. I was one of the co-founders of Envision Plastics. This June, I'll have 33 years of plastics recycling experience. I'm very outspoken and passionate on the subject of plastics recycling, but I just want to mention my very first job was at NewPack, which stood for New and Used Padding and Carpet. So I'm kind of excited that 32 and a half plus years later, I have joined PureCycle Technologies this past February, and we are one of the people looking to recycle carpet as well. Next. So this is PureCycle's timeline. So it started with P&G developing a technology in a lab and evolving that technology to multiple patents, where then we came in 2015 and licensed that technology from them. We slowly built what we would call a feedstock evaluation unit. FEU is how we describe it. And that was built in 2019. And then we were able to raise more money after proving to multiple customers samples from that FEU unit over the past year. And that money has now allowed us to start construction on our commercial line in Ironton, Ohio, which should be online by the fourth quarter of 2022. Meanwhile, we have gone public, we've raised more money, and we expect to build out 1 billion pounds of capacity by the end of 2023. Next. So this is just an example of a post-consumer bale of curbside material coming through. I probably should have switched it to a carpet sample, but I do have that coming up. It goes through a feedstock pre-processing, so that kind of eliminates the stigma that we had to have a pure polypropylene going into our system. We do some pre-processing of certain formats of polypropylene. The good news is we can take all kinds of formats. We have ran over 170 different samples in our feedstock evaluation unit. Out of those 170 plus, we have sent those samples out to a multitude of customers, and we are sold out 4 times over on the first plant that we're building commercially right now as we speak. It goes through an extraction, a filtration, and a product processing that gets it to a purely clean, almost like virgin polypropylene. What I like to talk about is it is not mechanical recycling and it is not chemical recycling. It is a solvent recycling system. We are basically doing what you would do if, here's a good layman example. If you were to accidentally put pepper in your salt shaker and you went, oh my gosh, I really need salt, but I don't like pepper. You could add water to it and that would be your solvent. Water would dissolve the salt, the pepper would float, you could filter it off and be left with salt water that can be converted back into salt. It doesn't molecularly change the salt, it's still salt. Just like that, we're taking a solvent that dissolves the polypropylene and it actually leaves things like colorant and additives that you might add to carpet like fire retardant or stain protection that would keep it from being a food grade material. We're removing those additives and it allows us to get back to a food grade type polypropylene. Next. So this is a video like the others.
Plastics
Enjoy.
recycling has been around for decades, but traditional mechanical recycling methods have significant limitations for polypropylene when it comes to quality and color. PureCycle Technologies uses a patented breakthrough technology resulting in ultra-pure recycled polypropylene while using dramatically less energy than virgin resin production. Our process begins with feedstock made up of reclaimed consumer packaging and many other discarded products traditionally destined for a landfill. Once melted down, the contaminated plastic is put into solution at unique conditions that start the purification process. The PureCycle technology process incorporates units of operation that have been in existence for decades, and extraction and filtration are at the heart of our process. These two simple concepts allow us to produce an industry-first, ultra-pure recycled polypropylene. During extraction, our process creates the ideal conditions where dissimilar things separate. Similar to how hot water can extract tannins from tea leaves, our process removes odor, contaminants, and other plastics from the polypropylene. From here, we simply alter the conditions to create an environment where similar things stay together. Much like how a coffee filter keeps the coffee grinds from flowing into the pot, our filtration captures color and tiny particles of contamination, resulting in ultra-pure recycled polypropylene. From there, we add back in the additives that the process removed and pelletize the resin, closing the loop on polypropylene waste. And that's it. Now our polymer is ready for your product, which can be recycled again and again. PureCycle Technologies is committed to the goal of increasing demand for recycled plastic by making virgin-like recycled polypropylene accessible around the globe. We are excited to bring our technology to contribute to the L'Oreal for the Future program. Our first plant, which is currently projected to be operational in late 2022, is expected to provide L'Oreal groups with 25% of their annual polypropylene usage today. But we're not stopping there. We plan to recycle polypropylene to fully support L'Oreal for the Future and our other strategic partners' visions as we all work together towards a common goal of a pure planet. PureCycle Technologies. One goal, a pure planet.
So thank you. That video said a lot what I already said before. Our very first run in that feedstock evaluation unit that was successful was with carpet. And so above is a sample of black carpet already pelletized for us. We put it in the FEU unit, and at 2 in the morning, those were the barrels of plastic that we made. Next. We then took that polypropylene resin and had it molded. And on the far left, you can see a molded pint-sized container with virgin resin. In the center was recycled carpet going into a pint-sized container at 100%. So you can see there's negligible difference. It's like virgin. And when we worked with our partner Milliken to add a clarifier to it, you can see we can actually make it even more brilliant than just standard polypropylene. Just like they could, we can add clarifiers to it. Next slide. And so thank you for having me today. I can't wait to answer any questions. I know some people are very still confused about solvent recycling, but we're happy to discuss. Thanks.
Thanks so much, Tamsin. Great visuals along with Chris's. I know that this is going to be a highlight of all these sessions. So PureCycle has the solvent recycling, Eastman has the carbon renewal and polyester renewal technologies. There's going to be a lot of interesting discussion at the end here. So thanks very much. And we're going to, again, hold the questions, but keep having them come in through the chat box, through the Q&A box. And next, now we're going to hear from Franco Rossi. Franco serves as president of Aquafil USA and its 3 subsidiaries, Aquafil Carpet Recycling 1 and 2, and Aquafil Carpet Collection. He's also a CARE California Advisory Committee member. Franco?
Yeah, good morning or good afternoon to everybody, according to where you are and where you live. I'm very honored to be here and to share the Aquafil experience with you guys. Just a brief word about Aquafil. So Aquafil, which I represent in North America, it's what we define a pocket-sized multinational. So we're not huge in size, but we are present in multiple countries and 3 continents. I would say that out of this slide, the most important number or information that you can see is the number 1. main raw material, nylon 6. So we were born approximately 60 years ago as a yarn manufacturer, and we have evolved into different kind of yarn, but for the very most part, we only use one single kind of plastic material, nylon 6. So we became very, very specialized, and our technology has grown significantly into that particular area of expertise of how you make nylon 6 and what do you make with nylon 6 and all the good properties of that polymer. Next, please. So I guess you perfectly understand this topic, what is the difference between linear, recycling, and circular. So recycling is pretty much a way of simply prolonging the life of some materials. It's definitely not a bad thing, but it does not really resolve the problem at the roots. It simply prolongs the life and delay the inevitable, which is for the used products to go and end up into incineration or the landfill. The circular economy is the one which can recycle itself forever, an infinite number of times, because the same product, the same raw material is manufactured over and over again using the old version of that same raw material or product. Next, please. So in 2011, Aquafil, based on the expertise that we have on nylon 6, has decided to launch the ECONYL project. So the definition of ECONYL is written over there. It's a nylon which is made out of 100% recycled resin, recycled material, and is made all of plastic scraps, either post-industrial or post-consumer. The most noticeable one in terms of post-consumer are fishing nets and old carpet. But then we use a variety of raw materials that I cannot even name how many we can use and recycle back into light new nylon. Next, please. So as you can read out of the slides, our product is indistinguishable from the nylon 6 made out of fossil fuels, the traditional way, and it can be recycled an infinite number of times. So it really perfectly meets the definition of circularity. Next, please. So ECONYL is not only a process, is a system. It's not only a product, it's a system. It's the system of rescuing and recovering old materials and is then regenerated, make it back into light new raw materials, and then make the product again, and then inventing whatever you can invent out of a raw material, which is not really based on material extracted from the earth, and make the same effort to design it to make it attractive for the consumer as you could make with any virgin nylon. Thank you. So it's a chemical recycling, just to, as we have heard about Eastman and PureCycle with their technology. It starts with some mechanical processing, but the real core technology is called depolymerization. So we pretty much unzip the chain of nylon and go back to the monomer, which is called caprolactam. And then once we have a caprolactam, we purify that material over and over until we are sure that we have eliminated all the contaminants. And by doing that, we pretty much skip the first two phases of the traditional way nylon is made. So there's no oil extraction, there is no oil transformation into different chemical intermediates and refinement of oil. And by doing that, as you can read in the slides, the global warming potential is reduced up to 90% compared to, as I said, the standard way of making nylon. And the good thing, you can do it over and over and over again. Next, please. So this is just some numbers to give a sense of what are we going to say for every 10,000 tons of ECONYL made. I mean, they just represent, some benchmark of how much we could achieve or we can achieve doing what we're doing. Next, I believe there is maybe a video. No, there is the old carpet story. The video is after. So, no, let's stay there, please. As I said before, Aquafil has developed this technology, and this system has been feeding the machine of the beast, as sometimes we call it, with different kind of feedstock. And at one point, as we are involved with the carpet industry as a fiber manufacturer, we felt like recycling old carpet could be a good opportunity for us, because carpet, for a good portion are made of nylon 6, and it's there are ways where you can extract that nylon 6 and use it as a feedstock to feed the ECONYL system. So next slide, please. So we established between 2018 and 2020 two carpet deconstruction facilities in Phoenix, Arizona, and in Woodland, California. And each facility has the ability and the capacity to recycle up to 36 million pounds of old carpet back into a raw material which can be repurposed. And a good portion of that 36 million pound is actually going to be the nylon that we need in Europe to feed our depolymerization unit. I suppose there is immediately a question why we're going west instead of any other states. And the simple answer is because carpet deconstruction is expensive. And California is the only state which has a legislation that helps carpet recyclers to pay for some of the cost associated with the deconstruction itself and to the repurposing of an unwanted raw materials like the filler, for instance. Approximately 50% of the carpet is made out of calcium carbonate, which is the filler. And that's a raw material which has zero market value, pretty much, actually 1 penny per pound when it's pure. And it has a negative market value when it's contaminated by latex and glues. So evidently, deconstructed carpet, the way carpet is made today, it's a very expensive activity. And so I want to reiterate also, when we talk about, and we've heard about PET and PP, that yes, this adventure are wonderful, and carpet is a good source of PET and PP too. But first of all, you need to extract those materials from the carpet. And that's not an easy thing to do. And as you probably all know, carpet is not recycled anywhere else in the United States out of it in California, because at market cost and values, there is no purpose and there's no economical reason to recycle carpet. Next, please.
Sustainability
there should be a video,
is one of the
right?
world's most pressing issues. The Prada Renylon project is crossing 5 continents to connect with upcycling initiatives that are turning harmful waste into pristine new products. Actor and activist Bonnie Wright and National Geographic explorer Asher J are in Arizona to uncover one of these stories.
I never really thought about carpet being such a big waste problem. Billions of tons of carpet is tossed aside annually into landfill. It's a huge environmental issue that no one's talking about. But there's this place in Phoenix that's found a way to transform this trash into treasure. Wow, so I've never been to a carpet graveyard before. It's amazing that these guys have conceived of a way to make a waste product into something valuable again that we can use. We seem to know about plastic bags and straws and fishnets, but no one's really talking about carpets. Why is that? What's the deal with carpets?
Used carpet is not a sexy subject, but there are 3.5 billion pounds of used carpet that go to landfill each year, and they can stay there for centuries. What we do is basically we deconstruct the carpet. We remove the heavy components, which are the ashes. And at the end, we separate the polypropylene and the nylon fibers.
These are the core components of everything from high waste to high fashion. It's real-world alchemy.
And this is nylon 6 that can become anything from camping tents, ropes, to Prada bags.
You're taking a linear supply chain, which goes from raw ingredients, product, to becoming waste, into a circular economy.
Now we as consumers can finally begin to invest in these materials that are really promoting a healthier environment. All products have stories. How they're made affects lives and affects the planet. It's a responsibility we carry too as consumers.
Okay, thank you. So I'm back here. So we visited a slide talking about the investment that we just made in 2021 in carpet collection facilities. Because yes, one thing is having the machinery, the equipment to deconstruct carpet and to extract what we want. But then, the procurement become the next hurdle, the next obstacle. And so as carpet collection is still insufficient to feed all the possible streams of utilizations and products, we decided to invest even in this other adventure and try to help the carpet collection mission, try to get more out of the landfill and eliminating landfilling. So yes, we have now, and you can go to the next slides, 3 collection points, 2 in Arizona and 1 in California. And on top of that, we of course the 2 plants we mentioned before, the Phoenix and the Woodland plant, which process and deconstruct carpet. So on the East Coast, we make the product, the fibers. In North Carolina, we make fiber for garment and apparel and upholstery. In Carterville, Georgia, we make fiber for carpet. One thing that I would like to add before we go to the next few slides is that when we talk about circular economy, and especially when we talk about carpet, I think we are taking the problem from the wrong end. We're looking at the end, so trying to bring back to life something which has not been designed to be recycled. Just the opposite. It has been designed to be durable. So the real revolution would be to design product in order to facilitate the end of a life destiny. That would cost much less money at the very end. Now we are here talking and say that we can only do it in California, or because of the legislation, because of the subsidies, because carpet is not built to be destroyed. It's not built to with some elements that can be easily separated or can be used together. They are glued, there's latex, there's any kind of contaminants. And this is why we need the government or the public legislation to subsidize the deconstruction of it. But the real solution to circular economy is starting from the beginning, starting to design products which are easy to recycle, not starting from the end and trying to recycle or deconstruct or reuse something which is not built for that purpose. So then you can go quickly to the next few slides. So just to say that ECONYL has become a brand name as an ingredient, and there are now more than 1,000 brands which uses that same ingredient, because it's a real story, because a lot of brands have embraced sustainability and circularity, and so we'll keep pushing our mission toward a circular economy, and we'll like to grow even further using ECONYL, which, as he said, is indistinguishable from nylon, but it performs exactly as nylon. Thank you.
Thanks so much, Franco. Really appreciate that presentation as well. We'll now move on to our final speaker here before we get to Q&A. Let me just mention, thanks so much for all the questions in the Q&A box. If people cannot answer those questions, I'd appreciate it. We want to make sure that we have these questions asked for everyone to see and hear. at the same time. So I will be asking those questions as we go through it, and hopefully people can stay past 3. We'll get the answers to these questions if you can't stay past 3 o'clock, but that would be awesome. Thank you. All right, so our final speaker here in this panel is Doug Mankosh. Doug is the CEO and founder of RISE Composite Technologies. His company's patented manufacturing process compresses carpet fibers and other synthetic materials into durable, attractive, and affordable wood replacement products like siding and trim. Doug, the floor is yours.
Hello, everyone. Thank you, Scott, and we appreciate the opportunity to speak with you today. RISE Building Products is the second company I've owned that has been in the recycled industry, creating building products out of recycled waste streams. My prior life was in composite decking. You may know the name of Trex, one of the lead players in that industry. Fibron was my company, and we recycled over 70 million pounds of polyethylene every year into recycled decking products. RISE Building Products was built basically around carpet as a feed stream, carpet fiber, and utilizes other recycled materials in building a very durable long-term trim and siding products for outdoor building materials. Next slide, please. So we focused primarily on the siding business as the majority of our product. Siding currently is largely a wood-based fiber product or a cementatious-based product for durable siding. Synthetic fibers effectively are utilized here to find a very effective long-term use and durability for exterior building materials that replace wood. Wood replacement in the building materials industry is probably one of the largest growing segments of the industry right now. Synthetics have taken over the exterior of most home applications and commercial applications due to their longevity and their performance over time. Slide, please. Thank you. We focus also, in addition to siding, on trim. What you can notice from the photography is the products are extremely wood-like. And the art of being successful in alternative building materials is to essentially imitate the original product that they are looking to replace. Synthetic fiber, when compressed in our operations plants, very much looks like all the wood products that it looks to replace in the marketplace. Next slide, please. One more, please. So it all starts here, and most of the development, we have 6 patents on this technology. The technology was a effort that we made starting in 2005, and our first of our patents issued in about 2009. It was all built around the concept of taking a very high volume waste stream and converting it into a usable form in the building materials industry. We focused on carpet just by the sheer scale of carpet that was being disposed of across the nation. The numbers jump around today. I've heard 3-point-something billion pounds of it. Originally, we were looking at 5 billion pounds, but it is a lot of pounds going in landfills with so little being recycled. And the shame of it is it's an incredibly good set of polymers. It's incredibly wasteful to take the polymers that are used in carpet, nylon, polyester, polypropylene, and essentially cover them with dirt for 1,000 years for them to decay. My view is the problem right now in carpet recycling is we view it as a waste stream, and what I do is I view it as a raw material. This form of product here we buy from at least 2 of the presenters, and one who isn't here, Circular Polymers and Aquafil, provide us our polymeric materials from their carpet recycling operations. And in addition to that, next slide, please. We're a very large consumer of packaging waste. We take both packaging waste and carpet, alloying and mixing them together, in addition to some of the automotive outputs in fiber, and we create a composition that goes into a compression process that I'm about to show you using glue and typical materials used in making plywood or particle board or some of the conventional wood-based building materials. Next slide, please. So the blended mixture looks like that. This is a very simple process, and watching the slides of Eastman or PureCycle, you know, with the chemical recycling, much more sophisticated processes, this is a basic process. This is essentially taking simplistically waste carpet fiber that has been granulated and prepared with waste plastic fiber or plastic materials, resonating them and putting them through a traditional panel-based wood processing plant and creating outdoor building materials from them. Simple and voluminous, large businesses. Next slide, please. In addition to the interior materials, we use phenolic resonated papers, which go on the top and the bottom. And as you may be aware, polymeric materials tend to have thermal expansion and contraction, making them difficult often in exterior environments. If you think about vinyl siding and the fact that it has to have room to move on the side of the house, or it will oil can or do other unattractive things. These types of carpet fibers and polymeric packaging materials also have similar properties. Phenolic paper acts, if you would, as the vise on the top and the bottom of the construct to keep the material extremely stable in the massive changes in temperature that it will see in its service life. If you think about what the outside of your house faces, it goes from potentially -25 degrees to as much as 150 degrees with reflective heat from the sun. Next slide, please. So the construction of our products, no matter which ones, they all look about the same. Paper on the top and the bottom for structural integrity, and then various layers of fiber, synthetic fiber from carpet and others in the middle at various lengths, combined with the other polymeric fillers that we use to make the product in our glue systems, which have been distributed in the product. Slide, please. After we complete them, we use exterior coatings for high performance, long life coatings, 15 to 20 years, to give them the visual attraction that the consumer wants when they install them. Slide. So our plant is in Minnesota, which is probably one of the coldest and hottest places you can be in the country. It's actually a great beta site for our products. It is a former particle board plant that we purchased, about 150,000 square feet, with large interior particle board presses that have been modified to handle the synthetic carpet fiber. Slide, please. To walk you through the process, which I'm about to do, it all starts here. These are bales of fiber that have been either created by Circular Polymers or Aquafil or Los Angeles Fiber, all coming from California. This year alone, we will consume about 10 million pounds of carpet fiber from California. And the plant's at full capacity will require about 35 million pounds. Next slide. So that carpet is taken through a series of processes. It is first guillotined to be broken as a bale, placed through a shredder to be liberated from its compressed state into a more fibrous flowing material. Next slide. And then it's granulated because we regulate the fiber size and the different layers inside the construction of the product. Longer fibers give us dimensional stability and strength. Shorter fibers can give us a smoother surfacing than the longer fibers might yield, making the surface more attractive. Next slide. It then starts what is a very large piece of equipment in a panel line, and we form a mat with the carpet fiber after we've resonated it through our systems. And the mat you see formed on the right for that product is about 11 inches tall, and we run every 10 minutes 80 feet of this mat through the presses. It's about 2,000 pounds worth of mat. So next slide, please. Prior to going to the press, we pre-press it so we can get it to a lower dimensional size prior to the press. And if you would, thank you for running that. We also place Excuse me, would you go back if you don't mind? Would you run that just a little longer, please? In addition to, at this step, we also begin to place the paper on the top. It's already on the bottom as it runs down the line and gets ready for compression. Thank you. We then move it into a very large press. This press is capable of putting 600 pounds per square inch on 2 5 by 40 foot sheets simultaneously. And we take that large 11-inch loft and we compress it down to about 0.75 inches thick, which you'll see in a moment. Next slide, please. You can start that film. So it takes a tremendous amount of power to compress these sheets, but that is the carpet and the polymeric fillers in the glued systems being now compressed from about 11 inches to about the thickness of that shiny bar, which you see at the top. We're going from a density of about 6 pounds per cubic foot to about 50 pounds per cubic foot as we make this compression. So it's large equipment, tremendously strong hydraulics to yield this process. And it's much different with wood. Wood would only maybe be a 4-inch tall loft as opposed to the 11. It's much easier to process wood, frankly, than it is to process the carpet materials for many reasons. This will continue to compress, and once it reaches its compressed level, it will take about 8 minutes for it to cure inside the press with the glue setting off and holding the panel in position after the pressure has been released. And this slow compression allows us to allow steam to escape and other things that are trapped in the panel so that it stays structurally in integrity. Next slide, please. After we complete the panelization and we remove it, we check density control across the sheet, make sure that we don't have any inappropriate densities. We begin to size the sheets. Typically, our lengths of products are 20 feet long, so the panels are cut into 20 feet. Next slide, please. The panels cool for about 3 to 5 days. They're actually at about, the press is at about 320 degrees. The internal panner temperature has to reach 220 to enact the glue, and it ends up reaching about 260. And those big sheets stacked up take a number of days to cool prior to be taken into a finishing process. In the beginning of the finishing process is the cutting, ripping, and molding, if you would, of the 5 by 40 foot sheets or 5 by 20 foot sheets as they may be into our siding width and our trim width, which run anywhere between 3.5 inches and 12 inches wide. Next slide, please. After that size change, we bring them through a very sophisticated finishing line where they're applied the various coating materials that we use to give them their longevity and their color attractiveness out in the field. Next slide, please. So in the end, what we're doing, and this is the whole business in alternative building materials, is taking essentially the older natural building materials that came out of the forest, the wood products, and essentially improving on them by using more modern materials, in this case, polymeric materials. But to be frank with you, the carpet products, the incredibly good nylons, polyesters, polypropylenes are significantly better than any of the wood-based materials in the exterior applications. They don't absorb water, they don't decay or mold. Their longevity is excellent. Their resistance to freeze and thaw is extremely good. They can come into ground contact without running the risk of fungal decay, and they look just like wood. So it makes it a very, very attractive alternative product, and obviously has a great use of what is a terrible landfill problem, and also replaces the cutting of the forest of the United States and around the world. Next slide, please. So the big thing that I'd like to impress upon you is that the current demand just in one product, in the siding product that I just showed you, for the United States is $10.5 billion. And if you look at the breakdown of the various types of sidings that are sold, there's about $6.5 billion of addressable market that our product would compete in. And what's important to realize for you, and this is why I tell you that we have to look at carpet fibers as a raw material, not a waste stream, is that if we just picked up 10% of the addressable market, or 650 million of the 6.5 billion that our products would fit into those categories, we could consume, based on our current plant, we could consume 1.3 billion pounds of discards a year just to service 10% of the addressable market of siding in the United States, which is simply just one building material. So 1.3 billion pounds of discards of the 3 or 4 or 5 billion pounds going into the environment every year in the US could be consumed in a 10% market share of one product in the building materials industry. And there are hundreds of products on the exterior building materials industry. And this type of volume is why we are foolish to waste the resources that we are using in products like carpet and others, packaging, films, as you saw earlier, when we can take and repurpose them into massive markets. And that is the message I want to give to you. We're not talking about dealing with a landfill problem. We're talking about providing raw materials to a market that exists. Between Eastman, PureCycle, Aquafil, RISE, this group probably can consume much of what could be collected in carpet in the United States of America. So it needs to be addressed. The programs of EPR need to go put in place in the States, and it's time to get to work. The problem is solvable. The technology is here. Thank you very much.
Thanks so much, Doug. Really appreciate that presentation. The only thing that made me squirm was the word guillotine there. So
yes.
Interesting process. All right, I'm going to invite the other speakers back in. So if you could show your video for those that are on this panel at least. And let's get to some of these questions here. For those that need to leave at 3 Eastern in a few minutes, we will be sending some of the questions in the Q&A that we didn't get to you afterwards. If you can stay, we're going to hear a lot of questions and answers here, so please stay if you can. All right, thanks for the great questions. So I'm going to just start from the bottom here. John Gilkison from Minnesota. Can someone address the end-of-life tip fee for carpet that is allowed under the California law and allowed in the Illinois and Minnesota bills, but not in the New York and Oregon bills? Long one here. What impact is the full waste tip going to have on the ability of stewardship programs to clean the carpet? I think that's enough for here. All right. So let me just, if you can talk about the end-of-life tip fee there. Someone want to get it? If you raise your hand, I'll call on you. Franco?
Yeah, I'm not sure what they mean by the tip fee end of life. I mean, you know, are we talking about the assessment that the consumer are paying when they buy new carpet in California, or what the tip fee would be the cost of disposal of carpet? If carpet is disposed in a proper way with one of the collection center, which are set up in California, there is nothing to pay. Obviously, if you simply go to the landfill will charge you with a tip fee, and that it varies obviously in terms of, you know, the county so there are different tip fees, but that is just simply based on weight, not really being carpet, not a carpet. In California, you need to go to one of the many, I think there are approximately 250 collection points in California between public and private, where you can discard your carpet and not really pay anything.
Yeah.
That's as far as the end of life. But I don't know if the question about the end of life or the assessment, the 35 cents per yard, which are paid by the consumer.
Complicated. David, you had your hand up. Do you want to answer that one if you can briefly?
I think Franco covered it at the end, which is from a tip fee perspective, you have a choice. You can go to your regular landfill just like you've always been doing at which point there is a tip fee, or you can, if you are a retailer, you can go back to, you can avoid the landfill. But today in all the different states, you have both options. And as a consumer, okay, there are public drop-off sites as well, okay, that do not require fees. There's actually a plethora of options depending upon what's right for either a business, a commercial establishment, a business, an installer, or a consumer.
Okay, thanks. Walter, you had mentioned this. So just very briefly here, the Illinois, you mentioned the $20 per ton sort of fee, and then other payments as well.
Yeah, correct. And, that was something when we were developing the Illinois law, we typically do have no charge to the consumer, right? But California did not have that. They do have a charge. And I think if you have no charge to the consumer, you're gonna have to have a higher subsidy, because some of the costs that are being covered by those tip fees would have to be covered by the producers.
Okay, thanks. Here's a question for Tamsin from Peter Spendolo. Can polyethylene be recycled using a similar solvent extraction technology?
Yes, so part of it's the solvent, part of it's the technology. So lots of universities have shown that different solvents work in this capacity in a lab. Getting it and making the process work so that it can be commercialized is the big challenge. And that's where we've come in and successfully done that on polypropylene. And so we are looking at, wow, if we can do it on polypropylene, there are a lot of other resins we should be looking at in using that type of format. So I would say the answer is yes, be on the lookout. I can't say specifically what our next resin is going to be. We're working on that diligently. I hope that answers the question.
Thank you. Here's a question that came up yesterday, and I'm going to direct this to Chris and Franco. It's directed here to Franco, but it's around the concerns that people have around chemical recycling. They hear the word chemical recycling or advanced recycling. There's immediate opposition. They think it's more in terms of incineration. And I'm wondering if you can discuss the benefits, but also the concerns that you see and how you're addressing those communication concerns as well. Let me start with Chris.
Yeah, so Scott, I mean, I've generally hear concerns in a couple different ways. First and foremost, most people think it's far out in the future, right? Not profitable. I think PureCycle, Aquafil, ourselves, we're demonstrating, no, it can be done today. The other concerns have to do with sort of the energy intensity, the environmental impact, the footprint associated with the technologies. Again, relative infancy, and so many of these haven't been demonstrated. So like Franco and Tamsin shared, we're trying to be as transparent as we can with regards to our life cycle data, emissions data associated with them. As I said in our key principles, right, we're only investing in these technologies if we're comfortable. We can demonstrate they have a lower carbon footprint, lower environmental impact than we could otherwise produce the products based on fossil feeds. The last kind of concern we often hear are, these technologies are a means to perpetuate single-use plastics. And again, as a principle from Eastman's perspective, 85+% of what we sell into are durable applications, right? Houseware, small appliances, medical devices. And so we absolutely believe, right, if you can reduce the amount of plastics you're using in the first place, we should. If you can find ways, reusable, refillable, we should do that. For that vast majority of waste, though, that reaches the end of its life, you need an outlet. And that's where I think these advanced recycling, the solvent-based technologies that Tamsin said, that's where I believe these technologies play.
Franco, would you like to follow up?
Yeah, well, yeah, I don't want people to get the impression that when we talk about chemical recycling, we picture out some mad scientist with some alchemies. I mean, using weird ingredients to generate some reactions. at least in our case, I can say that polymerization or depolymerization of nylon is simply based on water, temperature, and pressure. So there's no really any additives or any added chemical or chemistry which is used to chemically recycle nylon. When I say chemically, because that's to differentiate it from mechanical. And actually another advantage of chemical recycling is that you can really extract and properly dispose of all the called contaminants or unwanted material which are in the final products. So which we do. And so we remove potentially hazardous chemicals before they go back into the production cycle. And so, of course, you know, when you purify caprolactam as we do, we extract what we call muds at the end, and they are properly disposed as hazardous materials. So chemical recycling is actually the good way of doing things because there is no added chemicals. It's actually the removal of unknown chemicals, whatever you find in a product at the end of life.
So I have to apologize to Kate Carrera right here because I blew past her presentation. Your presentations came right up to the end, even past the time we were hoping to end the whole thing. So if you don't mind, folks, we're going to hold the rest of these questions. If you could put your videos, stop your videos for right now. I'm going to invite Kate on and apologize once again, Kate. I'm really sorry about that. This is going through one screen with multiple things I'm trying to bring up. So thanks very much for your patience here. And let me now introduce Kate. She is an attorney, expert in environmental policy and law with a vast experience working in international, federal, and state government bodies. And she is the deputy director of an organization called Environmental Advocates New York. And she's been very active working with PSI and others to develop the New York carpet legislation and advocating on its behalf. And Kate's going to be talking about sort of the environmental benefits of carpet recycling. What are we trying to protect? Kate?
Hi, Scott, and I totally forgive you. I actually, as Scott mentioned, my name is Kate Carrera. I'm the Deputy Director of an environmental nonprofit advocacy organization based in Albany, New York. And I actually, just for time, I think a lot of the reasons why I'm here today have been said in a lot of the different presentations that we've heard from the different producers and recyclers in terms of what is at stake in terms of our solid waste problem, our crisis with use of plastics, and the need to kind of reclaim some value and reprocess some materials. So I actually think that more value I may bring to this conversation now is just the experience that I've been in my involvement in working on the New York legislation for EPR. And that's really how I got looped into this conversation to the first place, and working with Scott on New York's proposals. So I think I don't need to necessarily go into the slide about, what the footprint of carpet, the footprint of solid waste in general of having on terms of our climate emissions, methane gas being such a potent greenhouse gas, and any efforts to reduce the amount of volume of waste going into landfilling facilities is super important and critical. Like, at the same time, the amount of waste that's going into incineration these days, because landfills are being stretched to their capacity, and for other reasons, curbside recycling markets also, very on tenuous ground, and more materials going into the incineration pathway is obviously extremely detrimental for climate change impacts. Next slide. I think this was just a little bit of a slide in terms of like how the life cycle of carpet, and if you're looking at it from the environmental lens, we've talked a lot about this already, just about the virgin carpet being incredibly intensive in using virgin resources. We've heard a lot that virgin carpet's often made out of plastics, which is made out of petroleum resources. We also have concerns in terms of our interest and our focus in the work that we do is not only in terms of reducing greenhouse gas emissions and working on that, but also just exposure to chemicals in our homes. We spend a lot of work trying to work on policies that will reduce our impact as well as our exposure to toxics in the home. And of course, you know, as I mentioned, the impacts from carpet from the disposal end of things. Next slide. I thought I would just touch a little bit on toxics, and there's been a lot of discussion in this conversation about PFAS chemicals and a lot of other chemicals that have been shown to be found in carpet. And there was a number of reports that have come out in the last couple of years just in terms of the different toxic components of carpet, PFAS being one that gets a lot of discussion. It's used as a stain repellent, and you know, I think there are even questions that I have understanding how that PFAS can be removed and then how it moves on to other products and how it perhaps is disposed of if it's removed from the product. But there are a lot of other toxic type chemicals that have been found in carpets. So there's all sorts of antimicrobial preservatives, the PVC, the polyvinyl chloride, which is typically been used in the backing as a binder, flame retardants, which have also been mentioned, as well as other adhesives used for installation. Next slide. I won't really go into this. This is just kind of like a nice description of where these different chemicals have been found in a kind of piece of carpet. Next slide. So this, of course, gets us to the benefits of recycling carpet. So we've heard a lot about promoting a circular economy, reducing the extraction of virgin resources, which of course contributes to reduction, helping reduce GHG, greenhouse gas emissions, also helping our transition off of fossil fuels, because plastics are one of, you know, our huge there's extractive resource to create plastics. So as if we can reduce that, we can reduce our dependency on fossil fuels in that sector. The landfill impacts, the incineration impacts, and then encouraging less toxic design. Next slide. I think this is probably the most important slide, maybe in some ways, of what value I can add to this conversation because of you know, I think we've touched on a lot of those aspects. It's just like how we try to influence New York's carpet legislation and New York's carpet EPR bill to accommodate for these environmental impacts and these environmental considerations. And certainly when I started working on the EPR bill in New York State, I really did come at it from obviously motivation behind it is let's get this bulky material that takes up a lot of landfill space out of the waste stream, and let's do something with it that's useful. And, you know, I think our end goal and our, you know, a lot of people on this call's desirability is to have a circular economy, bringing that carpet back into carpet, or, you know, a very another high quality use, as we heard, like siding and other aspects. So in the carpet, in the New York's proposal, and I know we heard a little bit about yesterday, but I'll touch on the components that really touch to the environmental aspects of it, is of course durability and content labeling. So knowing what's in the carpet, which I understand, you know, would help on the end in the recycling aspect of it. And I think that was, I think Franco was mentioning, and it was a really important point, is that carpet was never designed to be recycled. So it was designed to be durable. So having in mind, you know, how do you impact the design of the carpet to ensure that it can be remade into carpet again, or some other type of high use material. So New York's EPR proposal talks about content labeling. It has a ban on PFAS chemicals. That is the one chemical that we've explicitly identified in that draft legislation. But I think there would be room to add others to that list. The bill also talks about a phase out of permanent adhesives, which, as I mentioned before, can contain the polyvinyl chloride, or which release VOCs, which can be quite harmful to our health. The New York bill has very specific post-consumer content mandates. So driving that post-consumer content goals for recycled carpet. In addition, when putting together the stewardship organization or the product stewardship organization, being clear that the legislation calls for very specific performance goals about recycled content or recyclability of carpet as well as closed loop carpeting. I've kind of placed in here what the New York proposal outlines at the moment. Another powerful tool, which has been mentioned during the seminar, is just the eco design and the eco-modulated fee structure that really can help drive, I suppose that's the incentivizing side of this, to drive different design, less toxic chemicals, more post-consumer content. And then the last bit about in the New York proposal talks about a ban on discarded carpet. So A, helps remove it from going directly into the landfill stream, but also is then ensuring that there is enough carpet in the recycling network for the recyclers to have that feedstock or that resource. So I know I went real quickly, but I think that was all I really wanted to cover.
Awesome. Thank you so much, Kate. That was great. And I want to pick up on this and invite the rest of the speakers back in to answer some of the great questions that Kate has raised here. Let's start with the toxics. So this came up yesterday quite a bit. The carpet itself has toxics in it, as Kate mentioned. I think one of your slides said 40 something different materials that are in there. How does the recycling process, and if you could address this, how does the recycling process deal with the toxics and the contaminants in the carpet? And do we really want to be putting it back into carpet as closed loop? Or is there a way to take out those toxics and dispose of it as hazardous material? I mean, it seems like it's a problem, as Franco and Kate mentioned, and all of you mentioned. We want to design these differently so the toxics aren't there to begin with. What do we do now? Who would like to jump in first? Just raise your hand and I'll call on you. Or you can just jump in. Chris, looks like you're about to go. I'm going to call on you.
I'll jump in for a second.
All right, go ahead, David.
Clearly we want to follow the science, all right? And part of it is waiting for metrics based upon science to come out. In the meantime, we feel very fortunate in the sense of with our technology, we almost provide a dry cleaning, right? So part of the way that we get it so clean is by using some friction against the face fiber, okay, which removes a lot of whatever was put on that fiber to begin with. Having said that, some polymers, are more problematic than others. So PET carpet, right, which naturally propels liquid, typically doesn't get Stainmaster or other questionable products that I've read about in the press. But I think our headline is we want to follow the science. We just need the science to evolve a little further in regards to, the entire category of PFOAs, for example. So, we look forward to following the science, and then in some cases, let's look at RISE Building Solutions, right? They're taking mixed fiber, they are encapsulating it. The product lasts for 25 years, and then they're recycling it again and doing it all over. So, it's a pretty impressive process. It's a pretty impressive process. And then you've heard about some of the others, which actually the contaminants get removed in some of their advanced chemical recycling process.
Okay.
Yeah, Scott, I was going to build on that, and I think it was Doug in his presentation said these are sophisticated processes, and they are. So, as we look at carpet, right, the reforming process, fairly extreme conditions. So it breaks down PFAS, those other materials. And then those unit operations are followed by purification, other separation. So we're basically able to remove some of those contaminants. And then those materials are basically processed through existing solid waste management, wastewater treatment systems, such that the finished resin that we produce we're very comfortable with the safety, quality, performance of that to go on, and we have properly managed those impurities that we've removed from the process. Now, for clarity, right, we're learning every day as we try to qualify and process more of these hard to recycle materials. But up to this point, I think our experience has said we can deal with these impurities and properly manage them once they're removed from the process.
The question of how to take back your products once you make them is also, I've seen a couple of questions in the Q&A. So if it's clothing or if it's the lumber, even if it's lasting a long time, do you have closed loop return systems as well for those materials at this point? Or is that something that still needs to develop?
No, unfortunately, I can answer. Unfortunately, there's very few products or no product which really has an established system of reverse logistics. Because of the lack of economics and because of what I said before, the way products are engineered today. I mean, yeah, a few products you can name which has a sort of a system. For instance, a PET bottle or an aluminum can, they have systems, reverse logistics system in place. And the reason why that exists is because they're both pretty much made out of a single material. So they don't really necessitate any treatment center or any separation center. They're relatively easy to recycle because they are built in a way, I don't know if it's been made by design or just by convenience, which make them relatively easy to recycle. When you think about a lot of other materials, the effort of collection and what you collect, and how then to differentiate what you have collected is a gigantic undertaking. So just think about a garment. If you collect garment, you're going to collect hundreds of different kinds, hundreds of different blend and mix, and then you need to separate it, sort it out. It becomes impossible. It's still about, designing with the end in mind, and then everything will make more sense.
Okay. Here's a question. I'm trying to get the ones which are more general for each of you here. Kendall Christensen asked a question. In this era, nearly every waste recycling initiative also must be viewed through the lens of racial and environmental justice, whether it's eliminating toxics and other processing impacts, green jobs, etc. Can you comment on that? And I assume she's meaning, how does this factor into the location of your plants and the emissions and other factors like that?
I guess is the biggest one. We'll go first. So, yeah, I mean, when we look at our sustainability commitments as a whole, right? Climate obvious, circularity, addressing, and then a third part has always been this social aspect, caring for people. So, we've been operating major chemical facilities for 100 years. Each of those facilities has community advisory panels where we're making sure we're a good steward of the environment. We are a contributor to the health, welfare of the community, and we created an environment both inside our gate and outside where we're recognize the value of diversity and inclusion. And so as you talk about managing these wastes, those principles become even more important when we look at our kind of sustainability commitments overall. Scott, I guess at least from our perspective, that's the way we approached it.
Hey, Scott, I'll jump in real quick. We did add a provision in the Illinois law that the clearinghouse, the entity, I think a 20-some person entity, when the director makes those appointments, that the director was to look towards the racial and gender diversity of Illinois and try to reflect that on that board. So we did try to get that concept into, I know a lot of these EPR bills have advisory committees, et cetera, but so we tried to bring that concept into the formation of those types of bodies.
Thanks. Kate, I don't want to target you here, but I know you've done a lot of thinking on this. I'm wondering if you have any thoughts about, any suggestions or any things that the environmental community would like to see regarding the recycling of carpet?
Yeah, I mean, it's a good question. And I saw that question from Kendall before. And, the EJ environmental, the EJ focus, is something I haven't seen a lot of in this kind of recycling discussion, or at least in the EPR discussion that I've been involved in. And I think that's definitely an opportunity that we need to kind of fix. And I know we've been tackling with some of those issues just in New York with packaging and carpet as well. I think what Walter said, incorporating as part of these advisory groups, making sure that the representation of the right environmental justice communities are part of that conversation. I know that, a big focus for EPR, at least from the environmental perspective, as well as an environmental justice perspective, is like, we also want to reduce, right? And we often, I think when we talk about recycling, we are providing benefits, but we also can't lose sight that we have gotten to a point with the amount of waste we create just generally. And this may or may not, carpet is interesting. I think yesterday someone was saying it's kind of a declining flooring product. So as alternative products come on the market and replace carpet, so maybe it's a little bit less relevant for carpet, but certainly in terms of plastic, even recycling plastic, we want to get to a stage where we are more reliant on reusable products and creating less waste to begin with.
Thank you. Let me go to a question here, switching gears. Dana Barlow asks, can you give an order of magnitude estimate of the capital needed for a processing facility? And she mentions like the one in California, but each of you are involved in very significant investments. And Doug, maybe I can bring you in here. You've had a lot of experience working with with multiple businesses. Can you talk about the investment size, the magnitude of that? And then I'll quickly go to the others because we've got about a couple more minutes left here.
I think the recycling, the collection and recycling of carpet at approximately a 60 to 70 million pound capacity, which is the size of a lot of the plants that exist today. We estimate somewhere between 14 and say $18 million in capitalization for equipment, non-working capital. And when you look at a state, that's, for instance, California has collectible, it's not doing it, but it has collectible. It says 200 to 300 million pounds. You're looking at 3 or 4 of those plants to accomplish that at about, we'll call it $15-16 million for plant capital equipment. When you look at a processing plant like ours, the finished product plant like that, that's a very different equation. That's probably 4 or 5 times that multiple to invest in that plant at scale. So, but the collection and the destruction model, a lot of which we're interested in as various people, Aquafil, David, Circular Polymer, myself, I'm estimating in that range. David, Franco, you would agree with that estimate?
Well, I would agree. Well, let's say it depends how much destruction and reconstruction you want to do in that particular plant.
Mm-hmm.
Our plants for the capacity you just mentioned costed a bit more of what you said, but we go through several stages and we come out with a pellet, not with fibers.
Right.
And then if you talk about the second portion, which is the part that I call chemical recycling, so depolymerization and polymerization back into nylon, that definitely 5, 6, 7 times more of what we said.
Yes.
Because that's really, it's a heavy investment.
Yes.
Which is needed anyway if you want to do what you want to do.
Amanda, I want to check in with you here because you're our MC for the day. And should we continue or should we bring it in for a landing and answer these questions outside this call and send them to others on the phone?
Well, Scott, I think it is about time to wrap up. I know that some people have had to leave already, and thanks for prompting me here. I'd like to thank the speakers today who've shared some really fascinating material, and I wish we had a whole nother hour for questions because I know there are a lot. I know I have some.
A lot of great questions.
I would love to ask. But before some people do need to leave, I'd like to let you know that there is a survey that you'll see when you leave today's session. We would really appreciate your feedback. It helps us to create events that are desirable and good in the future, and we want to meet your needs. We did that already, but I will remind you that this session was recorded and yesterday's session was recorded as well. Both will be available on our website, both on the Carpet Symposium webpage and in the on-demand section of our website. And I would also like to point out some upcoming events we have at PSI. If EPR is of interest to you, we have an event tomorrow, our EPR Masterclass, the third in our spring series, on how to ensure a level playing field among multiple PROs, which is a growing area of interest in terms of a model for a program. Scott will be speaking again about sustainable flooring with Dow on June 9th. We'll also have an event on safe lights management, not just in the general community, but with a specific focus on environmental justice. And then on June 17th, we'll have a webinar with NERC and NMOA, two organizations in the Northeast that we work with, about the spectrum of approaches that states are taking to packaging EPR in the US. And with that, I will just thank the speakers again for their tremendous presentations and answers. And we hope we can have you all back for some more discussion at a later date. Scott, back to you.
I just want to thank everyone too, and thank the audience for staying with us. We had 2/3 that have stayed here. We're going to answer the questions. We'll send those that have not been asked, not been answered, to the speakers, and we'll get them back out. And please let us know what additional webinars you'd like. It seems like this one here, we could have a whole day, at least a couple of days. So it's fabulous. Thank you, Chris, David, Tamsin, Doug, Walter, Kate, and Franco. Awesome.
Thank you,
everyone. Bye-bye.
Thank you guys.